On this final example, we're going to try to put all of the pieces together and graph a rather unusual function. Something, of course, you would have done in like an Algebra 1 class for sure. Okay, we got f of x equaling x to the 2/3 power times x minus 6 minus x to the 1/3 power. Find the intervals on which f is increasing or decreasing. Find the local extrema values of f. Find the intervals on which f is concave up or concave down. And find all the points of inflection. And then put all of this together to sketch the graph. All right, are you ready? It should be a lot of fun. I think I'm going to need some extra pages here. Hey, no worries. I've got it covered. All right, so let's rewrite the equation down here. So f of x is equal to x to the 2/3 6 minus x to the 1/3. We'll have to use the product rule, of course, to take its derivative. So f prime of x is equal to, let's leapfrog this down, 2/3 x to the, subtract 1, negative 1/3. Derivative of the first times the second, plus the first one, x to the 2/3, times the derivative of the second one. So I'll have to leapfrog that power down, 6 minus x to the negative 2/3, and then you have to multiply it times the derivative of the interior because it's a composite function, and that's just going to be negative 1. You know what I'm going to do? I'm just going to put the negative right here where this plus sign is, and that should take care of it. Okay, so before we move on, we need to do some fancy factoring to clean this thing up for sure, because as it sits, it's going to be really hard to get some critical values unless it's written as one complete little fraction here. So I'm going to have to factor some things out. We're going to factor out a 1/3 first of all. All right, now let's take variables. X to the negative 1/3 versus x to the 2/3. This one's smaller, it's coming out. X to the negative 1/3. And then there's also a factor of 6 minus x common to both of these. And we've got 1/3 and negative 2/3. Negative 2/3 is the winner. It's the smaller one. Okay, there we go. And now let's divide each of these, see what is the quotient that's left over here. So let's see, 2/3 divided by 1/3 is going to be 2. And the x to the negative 1/3 divided by x to the negative 1/3 is just 1. It's gone. Okay, but I'll have a factor of 6 minus x. I do believe it's to the first power, right? So if you had a to the 1/3 power divided by a to the negative 2/3 power, you'd subtract those exponents. 1/3 minus a negative, or plus 2/3 makes to the first power. Okay, that's good. It's golden. All right, so get rid of that, clean it up, pretend it never happened. Minus the 1/3 is gone, x to the something. Well, if I had x to the first power times x to the negative 1/3, well, to the first power is the same thing as 3/3, and if I subtract out a 1/3, it makes 2/3. Okay, so it is to the first, and then my 6 minus x, that's just gone. That's what I factored out. Okay. So this will go down to the bottom. The 3 will go down to the bottom. This will go down to the bottom, and then we'll clean this stuff up inside the parentheses. Equals, let's see, I'll distribute. I have 12 minus 2x minus another x over 3x to the 1/3. Make that prettier. 6 minus x to the 2/3 power. Okay, and then up top I'll have 3 of those x's. Well, negative 3 of them. X to the 1/3, 6 minus x to the 2/3. Hey, take a look. Both of these have, wait a minute. Forget that. Both of these have a common factor of 3, and I've got a 3 down here, so I can divide both of these things by 3 and get 4 minus x over x to the 1/3 times 6 minus x to the 2/3. Whoa, it really cleaned up nicely, didn't it? This is beautiful. Anyway, so I need to get the critical numbers from this. Critical numbers are going to come from where the top's equal to 0, where the bottom's equal to 0. So let's do each one of these. Maybe I'd change over here to, green. Why that color green? I don't know. 4 minus x is equal to 0, which means x is equal to 4. So here's a critical number. What could possibly happen here? We could have a min and a min or a max. Question mark. Okay. Now we also have stuff from the bottom. Maybe this one gets purple, I think. Okay, so I have x to the 1/3 equaling 0. So, of course, x is equal to 0. Another critical number. And then I also have 6 minus x to the 2/3 equaling 0. Let's see, we'll raise both sides to the 3/2 power to make 6 minus x equals 0. Add the x over, of course, and we'd have x is equal to 6, another critical number. Again, what could happen on each one of these things? Mins and maxes. Let's use those to do a test for increasing or decreasing, and it'll also tell me where the minimum and maximum points are if you extend it off to the first derivative test. Here, let's just call it the first derivative test. Right? Okay. So we need some intervals. Wait, well, let's go back. What's the domain of this thing? So we're taking cube roots of stuff. It's raised to the second power, but taking the cube root, taking the cube root. Cube roots always have domain as all real numbers. So domain, all real numbers. We don't have to take anything out of it. So from negative infinity to positive infinity is what we're going to use. These critical numbers break up that intervals. Intervals. Negative infinity to 0. Reap. 0 to 4. Reap. And then what? 4 to 6. Right? We're going for, yeah. And then one more. We got 6 to infinity. All right, there's a lot of little intervals here to pick. And let's pick something, pick some sort of x value in each one of these, like -1, +1, maybe a 5, and then maybe a 7,000. I don't know. All right, where did these go? It's the first derivative test, so they're going to go into the first derivative. And we plug that thing in right here. So let me actually copy this down so I don't have to keep scrolling. Copy. Paste. And, I'll make it look like this. F prime of x. Okay, there we go. All right, there. Remember, all I need is signs. You can ignore probably the sign on this one is being squared. Right? It doesn't really matter what's going to go in here. This thing's going to be squared, so it's going to be positive here. So this part is a plus. Okay, so now it's pretty much just the rest of it's going to be plus minus stuff. So up top, if I were to stick in a -1, 4 minus a -1 makes this a positive number up here. So plus, and a -1 to the third power is going to be a negative. So all of this is going to be negative, which means that f of x is decreasing. We found our first decreasing interval from negative infinity to 0 because the first derivative is negative on that interval. Okay, so let's get rid of all this stuff and then plug in a positive one. If I plug in a positive one, I get 3 up top, which is still positive. This is positive, 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 positive. We have a plus here, which means that the graph is increasing. Okay, and then I'm going to stop here just for a second. I'm decreasing, I'm increasing. We found ourselves a relative minimum. Why? Because the first derivative changes from negative to positive at 0. Yeah. Okay, let's keep going. Keep going. Let's plug in a 5. Let's get rid of these things and plug in a 5. 5 is going to make this negative up top, but positive down here, so it's negative. We are now decreasing again. Okay, so increasing, decreasing. Here we found ourselves a relative maximum. All right, can we go ahead and assume that the next one's going to be a relative minimum? It's just going to alternate. Let's see. Go away. No. Go away. There we go. And what are we sticking in? 7. So definitely negative here. Positive. Oh, look at that. It's still negative. Which means it's still decreasing, and it's neither. Decreasing. Neither. All right, but I'm going to put a little something else together. So this graph all real numbers, it is continuous everywhere. However, look at where we found two of the critical numbers. So the 0 and the 6 that were down here in the bottom, they came from a division by 0. So it's where the derivative does not exist, right? So both of these things in purple, derivative D N E. Okay, so where can a derivative not exist? That's sharp turns, vertical tangent lines, and discontinuities. Well, we know it's not a discontinuity. It's either a sharp turn here or it's a vertical tangent line. Okay, if we have a relative minimum, this is at 0 right here. If we have a relative minimum at a particular point where it's continuous, but it's not differentiable, this one right here is going to be a sharp turn. Okay, now the next one here at neither, the one that's at 6, it's not going to be a sharp turn, probably going to be a vertical tangent line. I mean, we probably need to, well, let's see, if I did stick in, like if I stick in a 6, I am going to be dividing by 0, of course, but I'm going to have a number that is not 0 on the top. Its slope is infinity, so I'm going to say that this is probably a vertical tangent line. Vert tan. Okay, well, just to put all of that stuff together. All right, you still got some time? I mean, you may want to pause the video and go get a sandwich because now it's time to go take the second derivative of this thing. Hey, I've got a fresh page here. And if you remember, I can paste this yet again. And this time, when I find the second derivative, I'm going to have to use the quotient rule. Nice. Oh my God. And not only the quotient rule, but the product rule for the derivative of the denominator. Like I said, you may want to go get yourself a sandwich or something. Order some pizza. We're going to be here a while. All right, derivative of the top, -1. So just a negative times the bottom, x to the 1/3, 6 minus x to the 2/3. Minus the top, 4 minus x, times the derivative of the bottom. Product rule. All right, so the derivative of the first one is a 1/3 x to the -2/3 times the second one, 6 minus x 2/3, plus the first one, x to the 1/3 times the derivative of the second one, 6 minus x, subtract 1 from that, -1/3, I do believe, and then times the derivative of the interior. Wait, I forgot. You know what I forgot? I didn't leapfrog the power down. So a 2/3, 6 minus x to the -1/3. And then multiply times derivative of the interior, which is -1. And just like I did before, I'll just make this a negative sign right there. Okay. All of this over the denominator squared. So I'm going to take x to the 1/3, 6 minus x to the 2/3, and then square that thing. Oh my gosh. Looks rather intimidating, right? Well, we're certainly going to have to use some high-powered algebra here to clean this guy up. And the first thing that I'm going to do, I know this is totally unconventional, I'm going to distribute this 4 minus x, -4 minus x, to both of these terms in here. And I know that it doesn't seem like it's going to help, but it's gonna. You just take my word for it. Okay, so -x, 6 minus x to the 2/3 power, right? And then whenever I multiply this -4 minus x to all of this, I'll just have an extra set of parentheses in here, but a negative sign in here. -1/3 x to the -2/3, 4 minus x, and then 6 minus x to the 2/3. Okay, the negative times negative is going to cancel, make that positive. I'll bring this 2/3 out, so 2/3 x to the 1/3, 4 minus x, and then 6 minus x to the -1/3. Right? Okay, right? All of this over the denominator squared, which we can go ahead and square. So when you have a product that's being squared, the squared goes to both of these things, and it's just multiplying the exponents. So this is going to be x to the 2/3, and then 6 minus x to the 4/3. 4/3. Yes, lovely. Is this lovely? Is it lovely? I don't know. I think that's the wrong word. All right, now let's do some fancy factoring. What the heck did I do? How come nobody called me out on this? Exponent on this guy. It's supposed to be 1/3. Maybe I wrote it and it just didn't write. I'm going to say that's what happened. All right, so we got to do some fancy factoring. We're going to take out a third. We got a 1/3 here. We got 2/3. So we're going to take out a 1/3. Okay, what else are we going to take out? We're going to take out an x to the some power. Which one's the smallest one? It's negative 2/3, so that guy's coming out. X to the negative 2/3. Okay, we also have a factor of 6 minus x. It's like we've almost done this before. 2/3, no, not the 2/3. What's the smallest one? Negative 1/3. Okay, now then, I think that's all that we can take out. So let's see what we have to, what's going to be left behind. What's going to be the quotient here? So I'm going to have a negative sign, of course. And then this one doesn't have a fraction out front, so I need this to be a 3. Multiply 1/3 to get a 1 there, so 3. X to the first power, I think we did that one before, right? X to the 1/3 divided by x to the negative 2/3, 1/3 minus a negative mixed to the first. Okay, that's good. And then a factor of 6 minus x to the, I think, first power again. Isn't that the same thing? So 1/3 and 3/3 makes 2/3. Yes, that's good. All right, that's golden. All right, next one, I do have another negative sign. Maybe I should have factored out a negative sign. Who knows? Whatever. Who cares? The 1/3's gone. X to the negative 2/3 is gone. I do have a factor of 4 minus x. And then 2/3 matches up the other 2/3, so it's another 6 minus x here to the first power. Okay, on the last one, we're almost there. I'm going to have a 2 because I have a 2/3 here and I factor out a 1/3. X to the first, looks like. Another 4 minus x, and then I factored out 6 minus x to the negative 1/3, so it's gone, right? It's completely gone. All over this denominator again. Lovely. Okay, so the 3 is coming down, x to the 2/3 is coming down, 6 minus x to the 1/3 is coming down. We'll combine those exponents up. And then we have this atrocious looking thing up top. So I'll have a 3, x to the, adding those 4/3, and 6 minus x to the 5/3, adding an extra one to it. Okay. All right, now let's see, let's do some distributive property here. So this is going to be a negative 18x, and then plus 3x squared. Minus, and we'll have to do some FOILing. So 4 times 6, do you hear the joy in my voice? Oh my gosh. 24, and then let's see, I'm going to have a negative 4x and a negative 6x to make a negative 10x. And then positive x squared. And then distribute the 2x to both of these, a positive 8x and then minus 2x squared. Oh, it looks like it's cleaning up nicely. I'm going to get rid of these brackets and distribute the negative sign here. So plus there and a minus here. Get rid of that bracket. And then combine up all of our like terms. And hopefully we have 45 extra pages because we're not done yet. All right. Hey, look at this. This is so convenient. 10x, 8x makes 18x, positive of them. With a negative, they cancel out. Gone, gone, and gone. Not only that, we have a negative x squared, a negative 2x squared, that's a negative 3 of them, together with this positive 3, they cancel out too. Did you have your cancellation crayon handy? Because look at what happened. Can you believe this? Negative 24. It's the only thing that's left up top. Over 3x to the 4 thirds, 6 minus x to the 5 thirds. Well, hey, yeah, but not only that, 24 is divisible by 3, which makes this thing a negative 8 over x to the 4 thirds, 6 minus x to the 5 thirds. Wow, it cleaned up really nicely. I mean, that word nicely I'm using pretty loose. Fast and loose. Okay, we found the second derivative. We need to find some supercritical numbers, and that's where the top's equal to 0, but it's never, and where the bottom's equal to 0. Notice it's the same numbers that we had before. It's got a 0 here and a 6 from this one. So our supercritical numbers, x is equal to 0 and x is equal to 6. What could possibly happen here? This is possible points of inflection. Okay, I've been doing this so long, I'm not even sure of that word. Is it infection or is it inflection? Who knows? I don't know. I'll look it up later. Okay, so let's come back over here, and now let's test for concavity. This is not the second derivative test, because what does the second derivative test for? It tests for relative extrema, which we already have. All right, so test for concavity. Intervals, once again, it's all real numbers that we're going to break up. And we only have 2 of these supercrits. We got negative infinity up to 0, 0 up to 6, and then finally 6 to infinity. Let's pick something in each one of these, like maybe a negative one, maybe a positive one, and maybe 7. Maybe, just maybe. Well, okay. Now, since it's testing for concavity, that's dependent upon the second derivative. That's where these x values, these test values are going to go. Okay, so let's see. Let's plug in. I'm going to have to do this again. I'm going to have to copy and paste this. I don't want to keep scrolling. Copy. Paste. Oh, and I got this little scraggler down here. Go away, scraggler. Okay. Now, notice that no matter what, this x, or the top of this thing is always a negative number because it's negative 8. The bottom here, the x to the 4 thirds, it's always positive because we're raising it to the 4th power. The only thing that we really need to worry about is the x, the 6 minus x to the 5 thirds. Since it's raised to the 5th power up here, it could be positive or negative, depending on what we stick in here. So if I stick in a negative 1, that makes this a positive 7. Raise it to the 5/7 power is going to be 5/7? 5/3 power is still going to be positive. Negative divided by all positives, it's negative, meaning that our graph of f of x is going to be a concave down. It's going to be a CD. It's not one that you'd want to listen to by any means, but yeah, it's going to be a CD. All right. Oh, why did I take that one away? I wanted to keep that one. You should have been red. If that's red, I don't know. All right, if I put in a 1, here at, 1, that's 9 at 1, this is going to be a 5. It's going to be still a positive number. Negative divided by positive, it's negative. It's still concave down, which means that there's nothing here. So there's no POI, point of inflection. A POI. Now let's plug in a 7. So when I plug in a 7, finally we get a negative number here, negative 1 to the 5/3 power. It's going to be negative. and then negative divided by negative is going to make this a positive, and so then it's concave up. We've got a cup here. Get a cup, concave down, concave up. Boom, we have ourselves a point of inflection. Apoy. Whew, all right. I'm tempted to stop the video right here so I can go get a sandwich and come back and finish this. But hey, let's just keep going, shall we? Okay, so let's get some x and y, or some y values for all the points that we had. We have a point of inflection. We've got a minimum and a maximum point, and let's draw in a graph grid right here. This has got to be gray. All right, I need to go up to 6, I think. So 1, 2, 3, 4, 5, 6. I'll go ahead and throw in a 7. Okay, and then what the heck was our original function? Let's see if I remember this off the top of my head. 2/3, 6 minus x to the 1/3. I think. I'm going to have to scroll for like 14 years in order to get it. So did I write it down right? Yeah, 1/3. Okay. If I stick in 0 right here, yeah, this is the whole thing is going to be 0. So it's 0, 0. What could happen at 0, 0? So no point of inflection, but back up here, it was a relative minimum and it's going to be a sharp turn. Okay, probably a sharp turn. Definitely a sharp turn. Okay, what's the next one that we're going to stick in there? 4 was another critical number, I do believe. I'm going to need an extra page, I'm thinking. Add page. Add page. There we go. Okay, so if I stick in a 4, f of 4, I get, hey, come on, full screen. 4 to the 2/3 power. 6 minus 4 is going to give us a 2 to the 1/3 power. And you could do a little bit of algebra to clean this thing up, but I'm not gonna. I'm going to pull up this calculator. You're going to see this calculation already on here. It's looks like it is 3.174. Which you probably could have guessed at 3.174. All right, which we are going to approximate at the 1, 2, 3, 4. Let's say that's about right there. That's about if this whole thing is 4 going up, maybe that's 3.174-ish. Okay, what's the next one we got to plug in? We got to plug in a 6. Well, hey, if I plug in a 6 right here, this part is going to be 0 this time, so it's 6, 0. Wow, let's really zoom in. Bam. All right, we've got our points. Now let's draw in our graph. Okay. On the first interval from -infinity to 0, first of all, it's concave downward, so it's this kind of shape, I think. Well, is it decreasing? And it's decreasing. That's correct. So it's going to come down like this, decrease. Notice I made it a sharp turn because I think that's what we said it was going to be. Okay, from 0 to 4, well, from 0 to 6, it's all concave down. Right, so it's always going to be concave down here. And I think it's increasing at this interval. So increasing until we get to 4. And increase, but it's still concave down. It's decreasing past 4, right? Decreasing from 0 to 4, or from 4 to 6, I should say. It's decreasing because we have a relative maximum right there. But it's at this particular point that it changes from concave down to concave up, and this is our point of inflection. Okay, so you can visualize right here that we would have ourselves a vertical tangent line. All right, so there's the graph. Okay, anyway, let's see what the actual graph looked like if you were to, I don't know, maybe I have this on PowerPoint already graphed up. It's going to take me another 14 minutes. You got the time, right? You've spent this much time doing this problem. Welcome back. It's not this one, it is this one. So let's see how close we came. Does that look approximately like what we just drew? It sure kind of does. All right, here, let me Let me put this one right beside it. Let's see. Oh my God, it's like carbon copy. All right, there you go. We put all those pieces together. We were able to graph this thing by finding where it was increasing or decreasing, relative mins, maxes, concavity, and even a point of inflection, a bonus poi, point of inflection. We're done.